In this video, I'm going to introduce another concept where to find the angle between two straight lines in a space. So let's say you have two straight lines in a space, right? It's on a space. Where's how to find the angles between these two lines, right? So means the angle between the two lines. So let's say given the line L1 and line L2 have its own respective vector equation. For example, L1 you have R1 equals to A1 plus with T V1, right? And line 2, so you have let's say it's just a representation, so another point plus with lambda V2, right? This is two different lines, all right? Two different lines which can be parallel, can be non-parallel, all right? So to find the angle between these two lines, the most important thing is we need two vectors from this line, right? Two vectors, a direction vectors, means that for this line, line 1, we have its direction, right? As you know that this is a fixed point, this is a position vector, it's not a direction vector. So this is a direction vector which represents the direction of the line, right? The direction of the line. And the line 2, this is the fixed point, right? It's a position vector, it's not a direction vector. What we want is the direction vector, which will be the direction, represent the direction of the line, right? So the conclusion is, if you want to find the angle between the two straight lines, you need to know the direction vector of that line, of both of the line here. So the meaning here is the V1 and the V2 here. So how to finding the angle? Are we going to apply the formula for dot product? Alright. So if there is two vector for dot product, you will have a definition, right? The formula, which magnitude of A, magnitude of B, cosine theta, where the vector A and vector B, and this formula is using to find between two vectors, right? The angle between the two vectors. So what we're going to do now is we're going to apply this formula into the vector in geometry, alright? Vector in geometry space. Means the application of vector of dot product in finding the angle between two lines. So as the value of A and B now, the value of the vector now is represented by V1 and V2. So we can rewrite it to be V1 dot with V2 equals to, we just represent now the vector is V1 and V2. So which is magnitude of V1, magnitude of V2, cosine theta. Right? So it's the angle between the two vectors. So we can rearrange this. So later I will show you how to rearrange all this and finding the angle between the two straight lines. So, but this is the most important is, you know that you are applying the dot product formula, right? Into this straight line here to finding the angle between the two straight lines. Alright, okay, let's go on with example. Alright, let's continue with this example. How to find the angle, and this question specifies that we want to find the acute angle between the following two straight lines. So just now I have tell you that to find the angle between the two straight lines, you have to know the direction vector of these two from this equation of line, right? So which you apply the formula of V1 dot V2, the direction vector of the line 1 and line 2, magnitude with V1, magnitude with V2, cosine theta, right? So our target here is to find the V1 from this equation here. So we just rearrange, we were just enough to rearrange this into the parametric form. It's already enough for us to find the, to get the direction vector. So as you can rewrite this to be x minus 2 equals to t, and y minus 2 over 3 also equates to t, and negative z plus 4 over with 3 equals to t, right? In parametric form, so you will have x equals to 2 plus t and y equals to 2 plus 3t. Rearrange, and z equals to -4, -3t, right? 3t, negative 3t, negative 4. So from this parametric form, you can actually get, because the coefficient for t is actually the direction for the straight line. So I can get the v1. So the v1 here can is actually, okay, I write in column vector form. So 1, right, 3, and this will be negative 3. This is my direction vector for the first line, right? So let's get the direction vector for the second line. So very simple. So for this, I will going to equate all this into lambda, right? This one you have used t. The proper way of doing is you writing this in lambda. So x will be x minus 1 equals to lambda, right? X minus 1 equals to lambda, and y minus 1 over 2 equals to lambda, and 1 minus z over 4 equals to lambda. And you can rewrite this to be x equals to 1 plus lambda, and y equals to 1 plus 2 lambda, and z equals to 1 minus 4 lambda, right? 4 lambda. So bring over that side, 1 minus 4 lambda is z. So from here, you can identify your vector, the direction vector here. So because if you rewrite this into a vector equation form, you will find out that the coefficient for lambda will be the direction of this line. So 1, 2, and negative 4, right? So now I have already get the two vector, the direction vector. This is a direction vector for this line, and this is the direction vector for this line. All right. With this information, so because of the formula, right? So I rewrite the formula here. The formula will be V1 dot with V2 equals to magnitude of V1, V2 cosine theta, right? So based on the formula, we actually needed the information for V1 dot with V2 and the magnitude of V1 and V2, right? So at first, we try to find the dot product, right? Dot product V1 dot with V2. We find the dot product. So as a scalar product, right? You produce a scalar. So dot with your V2, which is 1, 2, negative 4, right? 1, 3, negative 3, 1, 3, negative 3, 1, 2, negative 4. So let's do the dot product. Very simple. 1 multiply 1, 1. Positive, positive, positive. 3 times 2, 6. Negative, negative, positive. 3, 4, 12. Right? 3, 4, 12. So 6, double check, 1. 6 plus 1, 7. 7 plus 2. So you will have 19. Right? 19. So if you get the dot scalar product, you get 19. And now you need, what you need is, based on the formula, okay, this, the value here you already know is 19, right? It's 19. So how to find the magnitude, right? The magnitude of V1, right? So this is the first thing. The second thing will be finding the vector, the magnitude of V1, which is the square root of 1 square, right? Each of the component, the coefficient you square, 3 square plus with negative 3 square. So what is the value that you get? And for V2, right, the magnitude of V2, which is the same as square root of 1 square plus 2 square plus negative 4 square. Alright, let's calculate what will you get for these two magnitude. For this, you are getting 9 plus 9, 18. You will get square root of 19, right? Square root of 19. And for this, you are getting square root of 21, right? Now you have enough information to find the angle between the two straight line, right? So 19, and here you have square root of 19 and square root of 21 for V2 cosine theta. And of course, cosine theta can be rewrite as 19 divided by square root of 19 square root of 21. And finally, your theta is the arc cos, inverse cos of 19 over square root of 19 square root of 21. Then you're using calculator in degree mode, you're finding the angle of between the two. Alright, which from calculator you key in degree mode, you were getting 19.97, right? 19.97 means that, 17.98 degree, right? To two decimal places, it will be 98 degree. Alright, so this is an acute angle, means that the two straight line, they will have the angle between two straight line, let's say line 1 and line 2. Alright, so this will be the acute angle between the two straight. Of course, there is also an obtuse angle between the two straight line. Alright, it's either obtuse or acute. Since the question requests for acute, then this is acute. So this will be the angle between the two straight line. Alright, hope you understand the way of finding the angle between two straight line. The most important thing is you have to know how to get the direction vector from the two straight line and apply the formula, and definitely you will get your angle between the two straight line. That's all for this video. We will go more example in the next video.